All right, happy Tuesday. Before we go and get started, if you have not already done so, make sure you get those first three submitted, right? The survey, the agreement, and the academic pledge. Get those in ASAP. Second, tonight is going to be the last night on techniques of integration. So tonight we look at improper integrals.
Our table is not today.
It's going to be available today after class. All right, so that's the bad news. Because we're finishing the first unit, your first test is going to be available tonight. It'll be due next week. All right, so once I post it, I'll let you know. Because I'll do it at the end of class. Yep. All right. Improper integrals. There are two types. The first type is the most obvious type. Where your interval of integration is infinite. Right, so one of the endpoints or possibly both of them are infinity. The way we handle these types of integrals is we take it as a limit if one of the endpoints is infinity. If both are, we have to split the interval and then take limits. The second type is more subtle. The second type is where the integrand itself, so the function you're integrating, has a discontinuity somewhere in the interval of integration. If it's one of the endpoints, we wind up with taking a limit. If it is somewhere between the endpoints, you have to split the integral at that point of discontinuity, and then each one you have to take a limit. So it is now important that whenever you're looking at an integral, you make sure the integrand is actually continuous over the interval. Because if you try to evaluate it normally just using fundamental theorem of calculus, you may get the wrong answer. Right, so integrating minus infinity to 0 e to the rx dx, where r is positive. Rx. Since we have an infinite interval, this is clearly improper. It's a type 1. Yes, I'm already in class. You can stop alerting me. Apparently, it's going to take me 6 minutes to get here. Gotta love GPS. Limit as a approaches negative infinity. It doesn't matter what you choose your limit variable to be. Book might use R. I use A or B.
Does it have to be from the left or right, depending if it's the lower or the upper?
Well, here it doesn't matter, right? You can't approach negative infinity from the left. But yes, it will matter when we deal with the second type of improper. Right, then instead of negative infinity to 0, it's a to 0. Right. So again, I use a or b depending on whether it's the upper limit or the lower limit. Right, b for the upper, a for the lower. Doesn't matter, you can use whatever the hell you want. Now we just evaluate this like normal. So we're gonna need an antiderivative, right? The 1 over r e to the rx x equals a to 0. Get 1 over r e to the 0 minus 1 over r e to the r times a. I'm going to write this now as 2 limits, just to make it explicit. E to the 0 is 1, right? So we're going to get 1 over r. And factor out that 1 over r. Because r is going to be some constant. Since 1 over r is constant, that first limit is just 1 over r, isn't it? All right, so limit of e to the ra is a approaches negative infinity. And this is where the r being positive is important. R is going to be some fixed value. Let's say 1. The argument's going to be the same no matter what value of r you choose. If a approaches negative infinity, the negative tells you what? It's just going to flip, isn't it? It's going to be reciprocal. So keep that in mind. As a gets larger, if r is 1, what happens to e to the a? But ignoring the negative part, I'm going to deal with that later. It's also getting larger, right? Because it's approaching negative infinity, that means the denominator is getting larger. So what's that limit? 0. So the integral is 1 over r.
Wait, so it's forgetting about the negative.
In my original analysis, I was ignoring the negative because I know it's going to just put it in the denominator, right? Raise e to a larger and larger power, what happens? It gets larger. So the denominator is getting larger. So that limit is 0, right? Because as the denominator gets larger, the fraction decreases specifically to 0. Right? It doesn't matter what value of R is since it's positive. The same is going to be true, right? No matter what R you put in. So we get 1 over R. Integral from 0 to infinity 1 over x squared plus 4. We again have an improper integral. Our interval is infinite. In this case, it's our upper bound that happens to be infinite, right? So I'm going to say this is the limit as b approaches infinity of the integral 0 to b of dx over x squared plus 4. Antiderivative 1 over x squared plus 4.
Natural log of the absolute value of x squared plus 4.
How did you get that?
About like
Specifically 1 over x. If you do use of, what's your u going to be?
probably some inverse.
You said it's going to be what? Okay. I don't see an x plus 4.
Dx.
Then what's du? 2x, which there is no 2x. I saw your hand next. It is going to be an inverse. It is, but we need to be more specific. So it is going to be an inverse tangent, but it's obviously not just inverse tangent of x. That would be if it was x squared plus 1. It's not. It's x squared plus 4. It is a basic. It's on Teams.
Okay, so I tried to find the specific that was in my. Not like a.
No, the basics are a complete list. Well, I say complete list in the sense that it gives you the power rule. Right, so it doesn't have every single polynomial listed. One half inverse tangent of x over 2. It's number 16. I usually am right. My wife will say otherwise, but I usually am right. For today's quiz, you're going to be able to. Test, you're not going to be able to unless I specifically tell you in the problem to do it. I haven't gotten to that yet. Right. So it'd be half inverse tangent b over 2 minus half inverse tangent of 0, right? Just evaluate it 0 to b. Again, just to be explicit, I'm going to split this into 2 limits. I don't know how long I'm going to be doing that. What is the inverse tangent of 0? Oh, what means? I actually don't even leave that piece. That's nice. Okay. If you cannot see this as it's written, try writing it this way. Do a change of variable. Say theta is b over 2. What does theta do then as b approaches infinity? How so? Theta also goes to infinity. Right, using that substitution, you can write the limit this way. May make it a little bit easier to see what's happening. Again, I'm probably not going to be doing that a lot. What is the limit of the inverse tangent of theta as theta approaches positive infinity? It's pi over 2. Our integral is pi over 4. By the way, if that limit were not to exist, we say the integral diverges. Integral 0 to 3 dx over the square root 9 minus x squared. Well, the interval's not infinite. But remember when we studied the fundamental theorem of calculus, there was an important condition in the hypothesis, was that the function is continuous over the interval. Remember that? F of x has to be continuous over a to b in order to use the fundamental theorem.
Function you're integrating, or it's antiderivative?
No, the function that you're integrating. So the integrand. 1 over square root of 9 minus x squared has 2 discontinuities. And then, of course, it's just not defined outside of -3 and +3. Has a discontinuity at -3, has a discontinuity at +3. Our interval contains 3. This is an improper integral. It is discontinuous at 3. So we're going to have to replace 3 with some variable and take the limit. But now here's the question. Do we really care about B approaching 3 from both directions? No, right? What direction are we concerned with? From the left. Right, because we're approaching 3 from 0. Because it's the upper bound. Once again, if this limit does not exist, then the interval diverges. If it does exist, the interval converges to that value. Right. And we only care about the left-hand limit, so we don't care if the limit doesn't exist from the right. That doesn't bother us. What is the antiderivative? And that'll go from 0 to B. What's the inverse sine of 0? Good, so that part is going to go away. So I'm just going to rewrite that. Now, as B approaches 3 from the left, how does the inverse sine of B over 3 behave?
It approaches pi/2.
The integral is pi/2. Yes. So the mathematical way to do it is to use the composite function theorem. So you look at the inverse sine, you go, okay, what's the domain of the inverse sine? Right? Inverse sine is a domain of -1 to +1. So the domain of the inverse sine of B over 3 would be -3 to +3. We're approaching 3 from the left. Is the inverse sine continuous at that point? 3. Yes, it is. 3 is in the domain. So it's continuous. So the composite function theorem says pull the limit inside the function. So what is the limit as B approaches 3 from the left of B over 3? So it's 1, right? Substitution. So it's the inverse sine of 1, which is pi/2. Right, so that's the mathematical explanation as to what we're doing. Yeah, just plug in 3 and see what you get. Pi/2. Yep.
Oh, okay.
Composite function theorem essentially says that's what you're allowed to do, as long as it's continuous. I say, and this is in practice, just plug it in and see what you get. If you get something that's undefined, obviously you can't do it. So we got to try something else. What, because of this class? What's your major?
Environmental science.
Oh yeah, this is probably the hardest math class you're ever going to take.
I know. I mean,
Wait, you need Calc 2 for environmental science?
what I'm
Really?
saying. I literally skipped the last 6 weeks of calc class last year because I was told I would never have to take calc 2, and now I'm like, no, you have to. Now I'm here.
Really? You need Calc 2 for?
If you do,
How do you need Calc 2 for environmental science for?
I don't have to do that assignment. Where we
It is-
Oh, no, wait. You might need it, yeah. I think you may have to take integrals in environmental science. So actually, it's just this first unit that's going to be really important to you. You're not going to need anything else after this.
Good.
Which actually sucks because everything else after this is easy compared to this stuff. What is the integrand? So just what is the integrand? What's the function? 1/2 minus x. Where does that have a discontinuity? What you just said. Is 2 in the interval? It is. This is improper. And approaching 2, how? What is that antiderivative?
-1 times the natural log of the absolute value of 2 minus x.
That negative allows me to just flip the order. Right, so instead of doing at B minus at 0, I'm just going to do at 0 minus at B. Just because I don't like writing a negative first. So natural log of 2 minus 0, that's a constant, isn't it? Right, and the limit of constant is just the constant, right? So that first piece is just going to give you log of 2. Now, as B approaches 2 from the left, how does log of 2 minus B behave? We can actually drop the absolute values. Right, since we're approaching from the left, 2 minus B is always going to be positive.
It approaches negative infinity.
That approaches negative infinity. So I'm going to say this approaches infinity. Keep in mind, I technically did a no-no. Because that second limit doesn't exist, I'm not allowed to actually split the limit. Whatever. That's why I'm not saying equals, I'm saying approaches. That limit does not exist. The integral diverges.
We don't say it approaches, like, we don't say there's an infinite area under the curve.
You could say it diverges to infinity. Because the limit doesn't exist.
Just diverge.
Doesn't exist.
So limits that go to infinity don't exist.
Yes. Because what's infinity?
It just means it keeps getting bigger and
Right.
bigger.
It's increasing without bound. That's a divergent limit. Right? It's never actually converging to something. It's never converging to some value. So it can't exist. The reason why we include limits being able to equal infinity and negative infinity is it tells us more information than just does not exist, right? So the fact that it's infinity just says that it's increasing without bound. If there's negative infinity, would say decrease without bound, whereas if it just doesn't exist, it could just mean that the function doesn't do anything.
So then why do we choose to say diverges there?
Because it still diverges.
Well, yeah, but that gives less information.
Not really. I don't really care about what the area is doing. I just know that it diverges. It's all your hand first.
Yes. So did we get the infinity from the natural log of 0? Is that where that's from?
In a sense. So it's not infinity. It's negative infinity, but yes. Right? Because what happens if you look at the graph of natural log, right? What happens as you approach 0 on that graph, right? It keeps going down, right? Because that's a vertical asymptote. That's why it's negative infinity.
I was just like, you plugged in the 2 for the b and then gave 0. So that's fine.
Well, not because it gave 0. Because that's how, if you look at the graph for log, that's how it behaves at 0. Right? Because what you would do is if you just went with that, right, you plug in 2, what happens? You get log of 0, which is undefined. So that's where you then have to kind of go, okay, so how's it behaving at 0, right? Now remember, it's 2 from the left, right? Which means that 2 minus b is getting smaller. So it'd be the same as x approaching 0 from the right of log of x. Right? If that was 2 from the right, it wouldn't be minus infinity. The limit would just straight up not exist because there's nothing to the right. It'd be like limit as x approaches 0 from the left of log of x. That doesn't make sense because the log doesn't exist to the left of 0.
So if it was from 0 to 4, it would make sense for the area to cancel out, right? Would it actually do that? Would it still say it diverges, even though there's still an equal amount of area at both sides?
Is there?
Well, yeah, it would be symmetrical.
Is it?
Yes.
What's infinity minus infinity?
Well, if you keep adding the area, like if
What's
you keep-
infinity minus infinity?
Well, we can't really do that.
Exactly. So it doesn't exist. You can't say the areas cancel out because you can't say infinity cancels infinity
Well,
out.
we could
That's
say-
not true.
We could say that let's say if you take from 0 to 1 and from like 3 to 4, that's going to be 0, of course, if you add them. And then you could say limit as that 1 goes to 2 and that 3 goes
Not
to
how it
2.
works. Not how it works.
That would make sense.
Not how it works. Weird stuff happens on infinity. Throw your common sense out the window. I showed it in Calc 1 last semester.
So if we-
There are different levels of infinity.
Well, yes, but those are clearly the same level.
Is it clear?
Yes,
You sure about that?
so the function is the same. If
Are you
took
sure about
one
that?
I was talking about, it would come out to 0.
You absolutely sure about that? Go ahead and
Yeah.
go ahead and do it. You'd
Okay.
have to split the integral up
Well,
at 2
yeah,
and
you
get
can.
those limits again. That limit does not exist, so the integral still diverges.
No, you wouldn't be splitting it like that. though.
Yes, you would. You'd have to split it at the point of discontinuity.
You could take 2 separate integrals
Right.
and go.
You're trying to make sense out of infinity.
Can I?
That's not how this works.
thinking then?
That is not how this works.
I mean, I believe that, like, that you're probably right about you not being able to do that, but I still don't see why you couldn't just put it in one big limit to show that it keeps going to 0.
Because you can't. Because we're going to split the area up at the point where it's discontinuous, right? So you have to split it at 2.
But you're not.
So you're going to have a limit from the left and a limit from the right, which does not exist.
You could write it as one big limit, though.
How?
I'll write it down.
What about here? What is the integrand? What is it? Where is that discontinuous? Is 1 in our interval? It is. We have an improper integral.
Could be it written out.
If you did that, the limit still would not exist.
Well, I mean, if you go evaluate the limit numerically, you keep getting 0 as you get closer and closer. So I would think that would make that limit 0.
We'll look at it later. So when you have the discontinuity actually in the interval, right? It's not an endpoint. You have to split your integral at the discontinuity. Oh, and by the way, it's possible that you have multiple discontinuities. In which case you'd have to split it at each point of discontinuity. Guess it would particularly suck if it was an infinite interval that had points of discontinuity. Then you'd have several limits that you'd have to do. That would be fun, actually. I'm going to need more space. All right. So we look at the first one. Well, that's much like what we've been doing. But that second one, the discontinuity is the lower limit. Here we'd have to approach from the right. Right, because we're approaching from 4. Antiderivative. 1 over x minus 1 squared.
-1 times 1 over x minus 1.
That goes x0 to b. Same antiderivative. We're just now evaluating it from a to 4. Plug in 0, you're going to get -1 minus when we plug in b. I'm going to start with a. We're going to get 1 over x minus a. I'm sorry. A minus 1. Then minus when we plug in 4, which is a third. It wouldn't then be minus -1. It'd be -1 over b minus 1 plus 1. Because of that negative on the outside. Right, because of that negative, I flipped the order. Right, because if you did it the same way, right, it'd be at b, you have -1 over b minus 1, right? Then you'd have minus that negative, so they would cancel, that'd become plus, but then you'd have 0 minus 1, which is -1 anyway. And I did the same thing here because of that because of the negative out in front of the function, I just flipped the order of evaluation. What is the limit of 1 over b minus 1 as b approaches 1 from the left? Does not exist. Specifically, it's negative infinity. Let's go. Which diverges. So the integral diverges.
Don't worry about second half or anything.
Nope.
Taking graphs, right? Does this one sheet have locations of the graph?
No. What is the integrand? Where is that discontinuous? Is 1 in the interval? This is improper. So you split your interval at points of discontinuity. Write these as limits. Now let's go ahead and evaluate. What is the antiderivative? 1 over cube root x minus 1. Bless you. Bless you. Yes.
2 times x minus 1 to
You're asking?
I'm pretty sure.
Or are you telling me?
Now,
Pretty sure. How sure is pretty sure? How much of your grade would you wager on that answer? Like it all or nothing, either 100 or a 0. That makes my grading very easy. It's power rule. It's the very first under the basics. I mean, technically it's a U sub as well, but the derivative is 1, so just treat it like to the 1/3 power. Zero to B. A to 4. Right. 3/2. B minus 1 to the 2/3 minus 3/2 negative 1 to the 2/3. That's what 3/2 times 3 to the 2/3 minus 3/2 a minus 1 to the 2/3. All right, tackle this piece by piece. As B approaches 1 from the left, B minus 1 to the 2/3 does what? It approaches 0. That second term is a constant. What's -1 to the 2/3? +1. That first limit evaluates out to just -3/2. For the second limit, that first term again is a constant. What is 3 to the 2/3? It's cube root of 9. As A approaches 1 from the right, what does A minus 1 to the 2/3 do? Approaches 0. There's our integral, which I'm going to simplify. Wait a minute. The only thing that changed was the power. In one case, it diverged. In the other case, it actually converged. This is a P integral. There are two types. One where it's A to infinity. Another where it's, what is it? It's A to some value, 0 to some value A. Right, go back through the video to look at them, look at the proof. Spoiler alert, P integral is going to be very important in Unit 3 when we study series. So you may want to write those two down.
So is -1 to the 2/3 1 or -1?
+1.
Because that's what I would think. Because you'd square it and take away the positive. But then I thought about how it'd be kind of weird to have the function jumping everywhere. So I put it into Desmos, and Desmos says it's -1.
Desmos is wrong. It's +1. Did you enter it in the right way? You don't have -1 in parentheses.
I see.
It's doing 1 to the 2/3 and then negative that.
That makes sense.
Right, it'd be the same thing if you typed it in that way and did squared, you get
Yeah.
-1, which clearly is not right. What is the integrand? Secant. Does secant have discontinuities? Oh, which one is it? You said no, and then and you said yes. So which one? No.
Yes.
Yes. How can you write secant? Wouldn't that be discontinuous if cosine is 0? Secant has discontinuities. Now here's the big question. Is it discontinuous over this interval? Where? I saw you nod. Where? Pi over 2. Secant of pi over 2 is undefined. Right, so we're approaching pi over 2 from the left. What is the antiderivative of secant? Close.
Natural log of the absolute value of secant x.
The limit as b approaches pi over 2 from the left. We get natural log of secant b plus tangent b. Absolute value. We can technically get rid of the absolute values because both secant and tangent are going to be positive. It's natural log secant 0 plus tangent 0. How does secant of b behave as b approaches pi over 2 from the left?
Goes to infinity.
What about tangent of b?
So goes to infinity.
This is zero.
Negative infinity. Pi over 2 from the left. Oh no! I'm approaching the wrong way. I was going from the right. Yeah, infinity. We cannot use the composite function theorem. Right, because secant b plus tangent b is actually not continuous at pi over 2. That's a problem. I think what I did here is I just plugged it into a calculator. But how do you know that limit does not exist? You can't just plug it in though, because it's not continuous at pi over 2.
Well, you can kind of see that both of them are just going to get larger and larger and larger as you get closer. And then when you take the natural log of the absolute value of that, that's also going to get larger.
Right, but you're again making the mistake of the composite function theorem.
But you're not actually plugging it in.
But you're using that argument, which is the same argument.
I mean, it's continuous up to that point though, which is all.
Right, but it doesn't matter. It has to be continuous at the point to use the composite function theorem. It is possible that limit does exist. Right, that's the weird thing.
Does this limit exist?
No, it doesn't. This limit is infinity. But I just plugged it into a calculator. So your calculator can take limits. Use it. That limit is infinite. This overall limit is infinity. Well, this one is actually, that value is just 0. Right? Because secant of 0 is 1, tangent of 0 is 0, log of 1 is 0. So you can actually just ignore that term. This is just the limit of this natural log, which is infinity. So the integral diverges. And yes, technically it would diverge to infinity. It'd be an infinite area. Any questions? I don't have anything hotkey, that's right. First test is now available. What you will do, complete the test on loose leaf paper. You have to show all of your work to receive full credit. Once you finish, you're going to scan your test as a single PDF file. All right, so multiple pages will be a multiple paged PDF file. When you go to upload it, of course, then you'll just upload that one PDF file. Question 5, you can upload a screenshot of your Mathematica file separately. You want to upload it as a JPEG or Word doc, whatever. Just make sure in the title it's clearly labeled if it's for question 5. Any other test file upload type will not be accepted. I don't want multiple PDF files for each page. I just want one PDF file. And then again, like I said, for the screenshots, that can be a separate file. That's fine. You're allowed to use your notes, your textbook, any other official course material. So the tables I handed out, you cannot use the integration table aside from the basic formulas and the 6 trig reduction formulas unless the problem tells you to use the table. Right, you're not allowed to use Mathematica to evaluate an integral unless the problem tells you to. Same thing with the calculator. You're not allowed to talk about this test with anyone but me. Right, so you can't talk about it with another instructor, tutors, yourselves, your mother, your father, little brother, maybe your 1-year-old brother who doesn't understand anything anyway. No, can't talk to it with him. Right, I will only answer clarification questions. Right, so ask me, what does this mean? I'll answer that. That's fine. You're not allowed to look the answers up online. Trust me, I'm probably going to know if you looked up the solution. ChatGPT does not yet do math. Does not yet do math, so don't have to worry about that yet.
We can do a little.
So can't do math. I don't have to worry about that just yet. Right. This will be due at the start of class next Tuesday. They have an entire week to work on it. Right, at the very top of your test document, just make sure you write out that statement. Right, that's basically just acknowledging and agreeing that you're not going to cheat on it. I had a lot of fun with this test. So this is a good test. I really like it.
Going to tutoring and ask for help on concepts.
Yeah.
Obviously not bringing.
You just can't ask for help on these specific questions.
You can't go. But you can ask for concepts around
Yeah.
the questions, like.
Yeah,
So
that's fine.
if we were to like change up the problem, like, can you help me solve this type of problem? That would be okay.
You can actually take the test in and show them the problem so they can try and find one that's similar to it. They know they're not allowed to do test questions, but they know that they can do similar problems. Most important instruction. Have fun. This is the hardest test this semester, so don't worry.
The other tests come easier.
Oh yeah, the other tests are way easier than this.
We can retake this with you, right?
Yep.
Insert that sound effect here.
I am going to warn you. Every semester when I teach Calc 2, the average on this test is an F.
Wow.
Even with retakes, it doesn't really bump the average up too much. But again, this is the hardest test. The other 3 tests are way easier. So, and the other semesters I didn't do that nice curving where the lowest test only counts for 5%. And students still wind up passing with a B or a C, even though they failed the first test. So you have nothing to worry about. It's even easier now that this will probably be the test that is 5% for everyone. I expect that to be the case. That sucks.
Yeah, it really does.
That means you get a different test.
Oh, easier one?
No, you get the honors test where it's all proofs.
That's bad.
Maybe I'll give you the Calc 3 test. Oh no, I'll give him the multiple integration test, which is a lot hard. You don't want multiple choice math tests.
25%.
Yeah, honestly, you know, at this point, I'm thinking of 0.
Because we know the mistakes you're going to make, and we make sure to include that answer in the multiple choice. So you look and you go, "Ah, my answer's here. It must be correct," and it's not. Oh yeah, we're evil. No, I don't. The curve is the way that the grades weight. Lowest test is only worth 5%. So think of that as the curve. And by the way, I don't think you understand what a curve really is. A curve does not just bump everyone's grade up. A curve is to force it into a normal distribution, which means the top people lose points and the bottom people gain points.
I've never heard.
That's a true curve.
That's how it be.
Right? That's what a true curve in statistics is. You fit the data to be normal. Well, obviously you did.
Oh, is this like,
No, this is this test.
oh.
Um,
Everybody-
Any questions about integration in general?
Have you thought of why that's not allowed, like that limit?
No, I've been too busy with. Yes. On Thursday, we look at applications of integration. It's going to get a lot easier. Do not wait until the last minute to do this. If you decide to do just one question a day, that's 5 days. You have 7. Yeah, it's only 5 questions.
do one a day.
I don't want there to be or extra hard. I am more likely to not have this time. I need more chances.
Not necessarily. I typically include one question that is really hard and sometimes one question that's really easy.
Wait.
Really hard on this.
I'm not going to tell you.
Is there a hard question on this one?
Oh, yeah. Look, I was even nice and gave you hints on 2 of the questions. I didn't have to do that. It's 5. There's only 4 on this page. The 5th one is Mathematica.
It's on Teams.
Yes.
Oh, that's-
So you're going to have to code.
Is that, that's not really hard, is that?
That better be a lie. No, chat GPT can go for you.
I'm sure.
Is the syntax gonna be correct? I don't know.
Wait for the quiz. Have fun.
That's what I've been waiting for.
Yeah, wait, 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 wait. Let me see, wait,
Oh, it's fine.
No questions.
Kind of stop it. Don't worry about it. Is it gonna be good or bad? Like, thinking about it.
Or after Sunday, it's gonna be bad.